In this video, we are going to verify trigonometric identities. First one is going to be secant x minus cosecant x over secant x plus cosecant x. Okay, and with green color I will show you what we're supposed to verify. So this expression is supposed to be tangent x minus 1 tangent x plus 1. Okay, so let's start. So first of all, we are going to use the following identity. Secant x is equal 1 over cosine x. Next, cosecant x is equal 1 over sine x. Also, tangent x equals sine x over cosine x. Okay, I think that's all for this case. So let's see. Secant, where I'm going to apply to secant identity number 1 and to cosecant identity number 2. So we are going to get 1 over cosine x minus 1 over sine x. In denominator also, we are going to get 1 over cosine x plus 1 over sine x. So let's bring both parts, numerator and denominator, to common denominator. So with in numerator having cosine x and sine x, cosine x and sine x, common denominator is going to be cosine x and sine x, right? So that is going to be equal here. Let me clean this. We already know sine to cosine. This is going to be 1 over cosine x. So we are missing sine, correct? So I'm multiplying by sine x here, sine x here, and minus sine x times here cosine x and cosine x on the top also. Same thing we're going to do to denominator, since we have cosine x and sine x. Common denominator is going to be cosine times sine, right? Which is going to be 1 over cosine x, so multiplying by sine x here and multiplying sine x on the top also, because whatever change we do to denominator, we have to do exactly same change to numerator, right? That's algebra. So sine x and times cosine x here times cosine x in numerator. What do we get here? So if I bring to now subtract on the numerator and add in denominator, I am going to get So cosine x sine x, and the numerator I will get sine x minus cosine x, right? In denominator I will have here cosine x sine x. Since our denominator are the same, so I just, with clean conscience, we can subtract, we can add sine x with cosine x. Okay. One second, let me make it more effective way written. So there we go. So from here we get practically sine x minus cosine x over cosine x and sine x divided by, because it's fractional line, nothing else but division. Here I get sine x plus cosine x, and denominator cosine x times sine x. Okay, so from here, once we do division, we are going to get sine x minus cosine x times cosine x times sine x. So it's a simple division of fractions. Whoever is need to refresh memory, you can go watch the video of division of fraction. That's on my basic math playlist. You can find there all operations of simple fractions. Cosine x sine x times sine x plus cosine x. What do we get? So we are canceling this with this, and result is going to get sine x minus, hold on, I wanna leave some space here, sine x minus cosine x. At the bottom I have sine x plus cosine x. Okay, this is what we got. So, but our goal is to get tangent x minus 1, tangent x plus 1, right? How can we tie up this sine x with tangent x? We know that tangent x is equal, formula free, identity free, tangent x is equal sine x over cosine x. Okay, we have sine x, so why don't we divide by cosine x also? Same thing I'm going to do to denominator. Cosine and cosine x. And what do we get? Amazing result. Cosine x is gone. So on the top, I will have in numerator sine x over cosine x. I'm getting identity number 3. So which will give me tangent x minus 1. At the bottom I will get, or denominator, I will get tangent x plus 1. So that's what we're supposed to verify, and that's what we verified. Okay? Moving to question number 2. We have tangent square 2x plus sine squared 2x plus cosine square 2x, and we need to verify that is indeed equal secant square 2x. Why I put in green color, so you won't think this is an equation. This is not. We have to just show that the tangent squared to x plus sine squared to x plus cosine squared to x indeed is, after simplification, is secant squared to x. Okay, let's start. So, tangent squared to x. I am going to apply here this formula number 3, identity number 3, tangent equals sine x over cosine x, which means tangent to x, actually no, we can go much more interesting way. Let me see. I'm going to, let me write down this formula. This will be sine x, sine square x plus cosine square x is equal 1. We know this, right? This is a formula 4. And I'm going to this one, sine squared 2x plus cosine squared 2x is equal 1. So that's, I'm going to apply formula 4. Now you can get confused, it's a sine square x and you have 2x. It doesn't matter. X or 2x or 3x, 4x, as long as n sine square and cosine square have the same angle, 2x, and 2, remember what it is, right? In this case, it's coefficient of x, nothing else but frequency. Remember, it's shrinking the sine and cosine or stretching sine cosine. If it's more than 1, then it's shrinking. In one period, you will fit, in this case, 2 waves. And if it's at less than 1, then you can, in 2 pi, in one period, you can fit only half of the wave. So whoever is interested to get that information, you can watch the video about amplitude, period, and frequency of trigonometric functions. Okay, so, and based on formula number 4, this is going to be equal 1, right? And we are going to get tangent squared to x plus 1, right? And if I apply, let me see, where is that formula? I don't have it written. I can apply with no problem. So we are going to add here formula 1 plus tangent squared x is equal secant square x. This will be our formula number 5, right? Coming here. Now here we have tangent to square 2x plus 1, because we have 2x. That means our secant also gonna be 2x. So we will get secant squared 2x. Very easy. Okay? All right. Moving to question number 3. So what do we have here? Cosine square x plus sine square x over 1 plus tangent squared x. So we need to show that is, after simplification, or verify that this expression, if we simplify, it's going to be cosine squared x. Okay, so let's start working. So I'm not, see, we have here formula 1 plus tangent square x. Look how I'm thinking. obviously I would jump to put secant square, right? Here, formula number 5, I would jump to put secant square, but I'm not going to do that. Why I'm not going to do that? Because look, in numerator I have cosine square x, sine square x, and I need to get cosine x. So I rather stick with sine and cosine and not to go towards secant. If I would have with green color, I would verify to get some value that would involve secant, then I would definitely take 1 plus tangent square x and convert into secant square x. But I am pursuing this expression to simplify into cosine square x. Therefore, what I'm going to do, I'm going to apply identity of tangent, and that is going to be, oh, here it is, formula number 3. Tangent x is equal sine x over cosine x. So what do we have? Cosine square x plus sine square x over 1 plus. Since we have square, so instead of sine over cosine, we get sine square x over cosine square x. All right, let's bring to common denominator. So since in this at the bottom 1 plus sine square x over cosine square x, denominator is cosine square x, then here I'm adding cosine square x. Here also I'm adding cosine square x. Okay, so what this will give me? On the top will give me cosine square x plus sine square x. You would say, might as well, why cosine square plus sine square? You don't put as a 1. I always can do that, get as a 1, but let's see, I might need it at the end, so I will wait till the end to see if from the expression at the bottom I won't get something like, again, cosine square x plus sine square x. Okay, you could, if you do to put it equal 1 from the very beginning, it's not gonna be big deal, because if you get the case where you have at the bottom cosine square plus sine square, you always can open that 1. Well, let me get back to this once I reach the end, so not to confuse you. Okay, so here we have cosine square x, and I get here, see, cosine square x plus sine square x. See, that's exactly what I was talking about. Look, here you have cosine square x plus sine square x, and here we also have cosine square x plus sine square x. Okay, so now I need to divide this. We'll write down cosine square x plus sine square x divided by cosine square x plus sine square x, and we divide by cosine squared x. So since it's division, I'm going to put here 1. Okay, so we can divide now. So when we divide, we do cross multiplication, or you flip the second fraction and do multiplication. And the bottom line is, either way you go, you are getting cosine square x plus sine square x. I don't have to repeat myself that there is a video in basic math playlist. You can go there and see how to do division of fractions. And here we get cosine square x plus sine square x. See, we can cancel this now. Can cancel this with this. Now, this is what I was talking about. Let's say you put the cosine square x plus sine square x from the very beginning here. Let's say you put it equal 1, right? So which means all the way till here you would come 1. So that's would be just fine. But once you see at the bottom here cosine square x plus sine square x, you should figure out real quick that instead of 1, I can put cosine square plus sine square and cancel. Okay? That's what I was talking about. But coming out from my experience, I could already see, once I wrote down this piece here in denominator, I could see that denominator is the same, so I will get cosine square plus sine square. That's why I kept it. Okay? So it's not a big deal again if you from the very beginning put it equal 1. So you can open later on again. And the result is cosine square x. That's what we needed to verify. Indeed, our original expression we simplified till 2 cosine square x. Okay, moving to question number 4. This is what we are going to solve for question number 4. 1 over, let's work now with secant, cosecant. Cosecant theta minus 1 minus 1 over cosecant theta plus 1. And we need to verify that it's equal to tangent squared theta. 2 tangent squared theta. All right. So secant theta minus 1, secant theta plus 1. Does it remind you formula, algebraic formula? A minus B times A plus B, and that is equal A squared minus B squared. Yes? That's exactly what we are going to use right now. Okay, I didn't mean to apply all. 1 second. No, that's not what I wanted. Well, I thought it will come out colorful, but not much. Okay, well, whatever. Wait, let's not waste time on this. So, which my A is going to be a cosecant theta, and my B is going to be 1. And as a result, we are going to get 1 over, we need to bring to common denominator, right? And common denominator will be cosecant theta minus 1 times cosecant theta plus 1. Yes? Okay. Move a little bit. Okay. So here we get, let's start here because I will need more space. We are going to get cosecant theta minus 1. Okay. So here I need to multiply by cosecant theta plus 1, correct? Same thing here. Minus, can't clean this because we already know denominator how much supposed to be. So it's going to be minus, in this case we are going to multiply this one, tan theta plus 1. We need to multiply by cosecant theta minus 1, yes? And we will get here 1 times cosecant theta minus 1. Okay, so what do we get from here? We are getting from here the following. Cosecant square theta minus 1, because that will be a square minus b square, right? Cosecant theta square, let me see. Square is equal cosecant square theta, right? And minus 1 square is 1, so we know that. Okay, so in numerator we have cosecant theta plus 1 minus, see this minus I'm going to treat as the minus sign in front of parentheses, which means it's going to flip every single sign within parentheses. That means this secant x going to become negative. I mean cosecant x theta will become negative, and minus 1 will become plus 1. As a result, we are getting these secants cancel, right? So what we're going to get from here? We're going to get 2 over cosecant squared theta minus 1. Okay, we came this far. So tangent, we need to get tangent square from cosecant. Okay, but we know that 1 plus, 1 plus tangent square, here it is. Let me shift a little bit these formulas. It looks like too crowded. Yeah, much better. So 1, the plus, where is it here? 1 plus tangent square x is equal secant square x. Accordingly, 1 plus cotangent square x is equal cosecant x square x, right? That will be formula 6. So, well, let's do drafting here. If I write down here 1 plus cotangent square x is equals cosecant square x. So if I move this 1 here, will be cosecant square x minus 1 equal cotangent square x, right? So that means applying formula to this one, applying formula 5, I believe, no, 6. Applying formula 6, we are getting 2 over cotangent square theta. So once we got to cotangent, from cotangent it's very easy to move to tangent. How? Because cotangent is equal, cotangent x is equal 1 over tangent x. And vice versa, tangent x is equal 1 over cotangent x. So we are applying formula 7. And the answer we get, since we have 1 over cotangent square theta, then we get tangent twice tangent square theta. See this, the fraction, it's the same thing, 2 times 1 over cotangent square theta. And this piece, this fraction, is equal tangent square theta. Okay? All right, we got it. So cotangent x equal 1 over tangent x, and tangent x is equal 1 over cotangent x. It's the same thing. Because we have here square, then we get square. Okay? Let's apply solve the last problem, question number 5. Also verification. So, sin t over cosecant t plus cosine t over secant t. And we need to verify that is equal 1. Okay, let's verify. So, I'm going to break down cosecant and secant based on identity that cosecant, it's formula 1 and 2. Secant is equal 1 over cosine, cosecant equal 1 over sine. So, first one comes secant. Okay. First is secant. Second formula is cosecant. So what do we get? Sin t over 1 over sin t plus cosine t over 1 over cosine t. Okay? That's mean if I divide, let me do some okay, I guess I can, yeah, I do some drafting here. Sin t divided by 1 over sin t. That is equal sin t over 1 times flipping, right? Sin t over 1, correct? So, we are getting here sin t times sin t. Same way we get cosine t times cosine t. And as a result, it's going to be sin square t plus cosine square t. And sin square plus cosine square is equal famous 1. Do we have this here formula, sine plus cosine? Yes, formulas. Let me see. Yeah, formula 4. Okay. Let me write down formula 4. That's how we got 1. Okay, that's all. Thank you for watching. So we will continue working together. I will keep sending a bunch of problems for trigonometric expression. We will solve trigonometric equations. Then I will cover polar coordinates, so everything that goes to precalculus. And then pretty soon I will start at the loading calculus topic also. And basic math also I'm going to fill up with a lot of basic math important topics, because those are fundamentals for math, calculus, and all above math subjects. All right, thank you for watching. See you at next video.